All right, so statistics. What's statistics made up of? Well, it's all about a piece of data, which is called a datum. See, datum is singular, data is plural, okay? So it describes a single quantity of some phenomenon. So in statistics, data, so all the datum together, is represented by random variables. And a random variable we saw, it's some function. We could end up writing there's some function, the value of which is going to be a real number, which is determined by the probability, and there's that link between probability and stats associated with how often the outcome happens. So random variables, they can be numeric or categorical. Random variables, they can also be continuous. So continuous is if the range of all the data is an infinite set of real numbers. So in other words, it's like an interval of values. It could be anything in the interval. Whereas discrete is if you could physically count the range. So it's countable. So you've got individual pieces of data. So we're concerned with techniques for describing stats. So descriptive stats, which is all the collection of the data, presenting it and summarising that data. And then the other part of stats is the inferential. That's when you can go and use that data to make predictions. That's what actuaries do. So descriptive stats, basically simple summaries about the data. Now they could be visual, so tables, graphs, charts, all those sorts of things. It could be quantitative. So if it's univariate, that just means one piece. So measures of central tendency, mean, median, mode. Measures of spread, variance, standard deviation, range, interquartile range, all of those sorts of things. Whereas bivariate data, which is where you're comparing two pieces of data, we talk about correlation and lines of best fit, which I guess you've probably seen a lot of in science, drawing up your lines of best fit. So the visual summaries. Frequency tables is probably the first type where we gather our information. So numerical and categorical data can be put into a frequency table. But numerical data we can also put into a cumulative frequency table. You can't do a cumulative frequency on a categorical data because how do you add up blue and red or something like that? You can't do it. You know? So here's a quick example. 20 students asked how many pets they have. And there's our results. Now, the tally is the first method we probably saw of how to record the data. So let's do that. Let's fill in our thing. So there's our tally marks all put in. And then, of course, we can then read off the tally to get the frequencies. Contingency tables. Now, that is a two-way table is another name for it, two-way table. And that's good for categorical data, actually. And really good for solving conditional probability problems. So something like this. Here's an example where we're recording two pieces of information about people. One is their eye colour and the other is their gender. And so there's all the different data for that. And so the question is being male and having green eyes, are those two things independent of each other? A reminder how we can tell independence using conditional probability. Well, one of the ways we can do it is we say the probability of A, given that B happens, is the same as probability of A. Because if they're the same, it basically means that B had no effect on the answer. So probability of male, well, reading off our table, there are 82 out of 167, so about 0.491. Now, probability male and green eyes. So given that they have green eyes. So I'm only interested in the column green eyes because we know that has to happen. And so male in that one is 20 out of 35. And that's 0.5714. That's not the same as probability of male. So no, they're not independent. There is some sort of dependence there according to this data. So common sorts of graphs and charts that we should be familiar with. Of course, we could have put that pet information into our line graph. Column graphs we did. Oh, good old pie charts, also known as sector graphs. There's a bar chart. I mean, bar charts and column graphs are pretty much the same thing, but we usually call it a bar if it's horizontal and a column if it's vertical. Dot plots, they're fun. Yeah, the plots. So all sorts of different types of graphs and things that we've seen. Pareto chart. Are we familiar with Pareto charts? Okay, well let's have a look at what a Pareto chart is. It's basically it's used when they're looking at defects and things like that. So it indicates the frequency of defects as well as the impact. So it's good for some business that wants to try and minimise their defects to look at a chart like this. So basically it's two graphs on the same. You have a frequency histogram, but arranged in descending order. And then you have a cumulative frequency polygon as well on the same graph. So here we go. Here's the data that we've got. So the different defects, we're making shirts. So there was something wrong with the button or the pocket or the collar or the cuff. And so I've got the frequency there, but then I've also worked out the cumulative frequency because I'm going to need that for the cumulative frequency polygon. There's the graph. So the histogram, which remember is the column graph, in descending order. So my columns are going down in size. The polygon is the line graph. Now you'll notice I've got two different scales here. The left scale is frequency. So that's used for the histogram. And the right-hand side is the cumulative frequency percentage. It's obviously used for the polygon. Okay. So the question for this one is, we could look at this and say, well, if we eliminated, we just worked on eliminating the buttons and the pocket defects. That will get rid of 66% of all the defects. So rather than focusing on everything, I can still get rid of half of the defects by just looking at two of the things. That sort of chart is what we call a Pareto chart. So quantitative summaries, central tendency. Okay. Mode happens the most often, and in our pet example, one pet was the mode. A mode is not necessarily unique. You could have two modes, and that's what we call bimodal. You could have three modes, trimodal, but we usually then don't keep going. Anything above that, we usually say, okay, it's multimodal. Median, so the middle score. If you have an odd number of scores, then you're looking at the middle score. Again, they've got to be arranged in order. I've said in ascending order, but I suppose there's no reason why it couldn't be descending order. It's still going to be the middle one, isn't it? But if you've got an even number of scores, then you can't get one in the middle. So you get the two in the middle and average them. And that becomes the median. Now, our example, we had 20 scores. So that's an even number. So I want the average of the 10th and the 11th. So the median is 1.5 pets. Now, obviously, you can't have 1.5 pets unless there's been an unfortunate accident. Measures spread. So range, maximum minus minimum. So our pet one would be 4 pets. Now, you can only have a range with numeric data. Again, you couldn't say what's blue minus red. I mean, it just wouldn't work. All right, so 15A, our first example, our first exercise for the term.